Hello Year 5, I hope you're doing well. Welcome to Wednesday's maths lesson, and today we're continuing looking at conversion of units, and we're going to look at centimetres and metres today. But just like yesterday, we've got a starter today to warm up our brains because we need to recap how to multiply and divide by 100. So just like yesterday, we're not going to look at this page on the PDF because we've got a PowerPoint version that we can look at. So grab some pencils and paper, something to write on, and pause the video if you need to, okay? Okay, so let's recap multiplying by 100 first. So I've got my Gategno chart back again. Let's look at what happens when we multiply a digit by 100, okay? So 1 times 100 is 100, okay? Think about the position of the digits and what happens. Can you remember the rules, okay? Let's look at the next one. 2 times 100 is 200. 3 times 100 is 300. You might want to join in with me. 4 times 100 is 400. 5 times 100 is 500. I'm going to click ahead now, and so as I click ahead, really think about what's happening here. Okay, so hopefully you realise that when you multiply by 100, we're actually skipping a row now, aren't we? So instead of moving our digit 1 place to the left, we're actually moving our digit 2 places to the left each time, okay? Now let's explore this a little bit more in a place value chart. So again, I've got my ones, tens, hundreds and thousands, but remember we could have tenths and hundredths if we carried on this way, or we could have 10,000s, 100,000s if we carried on this way. So it doesn't stop here. Okay, so let's imagine if we had 1 and we multiplied it by 100. Where do you think that digit 1 will end up and why? Have a think about that. Okay, so our digit 1, to make it 100 times the size, we're going to move it 2 place value columns. So our 1 ends up in the hundreds column. And of course, we'd need to put our place value holders in, wouldn't we? So we'd need a 0 in our tens and a 0 in our ones. So 1 has been made 100 times the size. Okay, grab your pens and paper and see if you can do this one, okay? Let's put 6 in our place value chart, and let's think about how to make it 100 times the size. Okay, what are you going to do? Okay, so hopefully you knew that you needed to move the digit 6 2 times to the left this time to multiply it by 100. So we've got our 2 place value holders. So 6 times 100 is 600. Okay, now let's look at a 2-digit number just to see if, make sure that we know that this pattern continues so that we have to move every digit the same amount. Let's put our 15 in the place value column. Now you think about what is going to happen to our 15. Okay, so we need to move each digit 2 places to the left this time. Okay, so look where it ends up. There we go. So we can just check this by looking at our ones column and thinking, have we made our ones 100 times the size? Well, yes, we have, because 5 is now 500. Okay, let's move 2 places. Now let's look at our tens. Have we made the tens 100 times the size? Yes, we have, because they have moved 2 places as well. They are now thousands. So 15 times 100 is 1,500, okay? So I want you to have a little go now. Here are some numbers. I want you to see if you can times them all by 100, and I'm sure you're going to be able to do this really quickly. So you can just shout them out, okay? Pause the video now. Okay, so hopefully you got on well with that, and here are our multiples of 100, okay? So counting in hundreds, it would be 0, 100, 200, 300, 400, 500, 600, 700, 800, 900, and then we would have 10 hundreds, but we call that 1,000, don't we? Now I want you to carry the pattern on, okay? So let's think, what would come after 9? It would be 10, wouldn't it? So what would 10 times 100 be? And then 11 times 100. See if you can pause the video now and write the calculations and fill in the rest of the table. Okay, super. So 10 times 100, you say them with me, is 1,000. 11 times 100 is 1,100. 12 times 100 is 1,200. 13 times 100 is 1,300. 14 times 100 is 1,400. 15 times 100 is 1,500. 16 times 100 is 1,600. 17 times 100 is 1,700. 18 times 100 is 1,800. 19 times 100 is 1,900. And 20 times 100 is 2,000. Now, what do you notice each time? Hopefully you've noticed that when we've got a 2-digit number and we times it by 100, if we've got a tens number, we always end up with 1,000 digits. Now think about that, that's the 4th column away, isn't it? So if we're at the 2nd column, we've got to move 2 columns each time. So a 2-digit multiple of 10, if we times it by 100, it will always be 1,000 number, a 4-digit number. Okay, let's look at the inverse now. So the inverse to timesing by 100 is dividing by 100, okay? Let's look at what happens. So 1 times 100 is 100. So now let's turn it into the inverse calculation. So we'll start with 100 and we'll divide it by 100. Let's look at what happens. We end up with 1. So as we go through the rest of these, say them with me and think about the pattern for dividing by 100. What's our rule going to be? So 2 times 100 is 200. Let's make it the inverse. 200 divided by 100 is 2. Okay, let's say the next one together. 3 times 100 is 300. 300 divided by 100 is 3. I'm going to click ahead now. If you want to stop the video and do the rest of them, please do. But think about that pattern. What do we do if we divide by 100? Okay, so hopefully you've realised that we need to move our place value, our digits, 2 places to the right this time, okay? We're making our numbers smaller, aren't we? So let's think about 900 divided by 100. Let's put our 900 in our place value columns, okay? What are we going to do to divide it by 100? Pause the video and have a think now. Okay, so we need to move every digit 2 places to the right this time. So let's see what happens. Okay, so our 900 digit moves into the tens column and then the nines column. Would we need to write these placeholders or would we just need to write 9? Well, we just need to write 9. But we have got to think about placeholders for if we have other decimals, like if we have hundreds, say. Okay, so 900 divided by 100 is 9. Now let's look at a 4-digit number. Now remember what we found out earlier about 4-digit numbers. Think about what we're going to end up with. Can you make a prediction? Okay, so let's put our 1,600 into the columns. Now pause the video and think what's going to happen if we divide this by 100. Okay, so hopefully you knew that each digit is going to move 2 places to the right this time. There we go. So we end up with 16. Okay, again, we don't need these place value holders for the moment. So there we go. 1,600 divided by 100 is 16. So just like before, see if you can now start with the bottom numbers and divide them by 100 to get the top numbers. You'll be really good at this, so do it really quickly and out loud. Okay, so there we go. Hopefully you have the same as me. Okay, all of our digits have been moved back 2 places to the right. They've been made smaller because we're dividing by 100. Now see if you can carry this one on. So we're starting with 900 divided by 100 to make 9. So think about what will come next. 1,000 divided by 100, what will that be? So go through and see if you can write down the calculations and fill in the rest of the table. Okay, so now you can say them with me. So 1,000 divided by 100 is 10. 1,100 divided by 100 is 11. 1,200 divided by 100 is 12. 1,300 divided by 100 is 13. 1,400 divided by 100 is 14. 1,500 divided by 100 is 15. 1,600 divided by 100 is 16. 1,700 divided by 100 is 17. 1,800 divided by 100 is 18. 1,900 divided by 100 is 19. And 2,000 divided by 100 is 20. Super. Hopefully that's been a good recap for you. Okay, we're going to need to apply those skills now. So here is your review task, and we're going to start to focus in on centimeters and meters now, okay? So pause the video and have a think. Okay, if you were finding this problem tricky, you might want to actually pause the video right now and see if you can go and measure out some strips of paper that are 10 centimeters in length, make 10 of them, and see what happens if you do place them end to end, okay? So if I place these 10 pieces of paper to end, this is kind of what I'm meaning. So if I have one like this, I put the other one next to it, and I'd want to know what the total length would be. So it's 10 lots of 10 centimeters, isn't it? Okay, hopefully you've realized that 10 lots of 10 centimeters would be 100 centimeters, but there's more than one way to describe that. Let me just write 100 centimeters here, and let me reveal a number line to you. Okay, now hopefully you remember from yesterday, from your flashcards, get them back out if you haven't done your flashcards today. Hopefully you remember that there are 100 centimeters in 1 meter. So we could count in our 10 centimeters all the way up to 100 centimeters, but we could also call that point 1 meter as well. Okay, super. Now we're going to need to use that information as we go throughout the rest of our lesson. So it will be there. Okay, we're going to think about I know and so again. Okay, let's learn. So there are these are the world records held for pole vault over the years. Now, pole vault is a really cool sport where you basically have a stick and you have to propel yourself, launch yourself over this really high bar, and of course this padding to land on. And these are the world records. So these are the people: Brian Sternberg, Thierry, I'm not sure about that, Vigneron, Renaud Lavillenie, something like that, French name, I guess. And we can see that their measurements have been put here in this table. Now, what do you notice about the heights? Can you pause the video and say what you notice about the heights? Okay, hopefully you've noticed that some of them are recorded in centimeters and some of them are recorded in meters. So we've got a mix of units of length at the moment. Now, I want to know, how would we write all of these heights in the same unit? So that's what we're going to explore next. So we're going to think about writing these measurements in meters first. So Brian's height was 500 centimeters. We can see it there. Can we write this in meters? So I want to know 500 centimeters equals how many meters? I'm going to use what I know. I know that there are 100 centimeters in 1 meter. So 500 centimeters would be 5 meters. Now you might want to pause the video for a moment and think about how I know that. What have I done there? Okay, so hopefully you've realized that actually there's 5 lots of 100 in 500. So if there's 5 lots of 100 here, there need to be 5 lots of 1 here, okay? Now let's look at actually what happens. How did I convert the centimeters to meters? Let's look at what's happened to those numbers mathematically. So how have I gone from that 100 to 1? I know that 100 divided by 100 will be 1. Okay, let's check with this one. So if we have 500 and we divide it by 100, we will also get 5. And that's because we've moved our digits, our 100 digits, 2 places to the right, like we did before when we were dividing by 100. So how did we go from our centimeters to meters? We divided by 100. So Brian's height was 500 centimeters, which is the same as 5 meters. Hopefully that makes sense. Now we're dividing, remember, because we're going from a greater number of centimeters, because each of our centimeters is a smaller part of a whole meter. So we want to end up with a bigger value, but a smaller number for that value. Okay, but it's equivalent, isn't it? So we've got 100 centimeters. We want to divide our centimeter amounts by 100 in order to get it to that small 1 meter. Hopefully that makes sense. Okay, let's carry on. So this is Renaud's height. So Renaud's height was 616 centimeters. Okay, can we write this in meters? You might want to pause the video now and see if you can have a go at this on your own. Okay, so we want to know, what is 616 centimeters in meters? So just like yesterday, I've taken my 616 centimeters and I've split it up, I've partitioned it into 600 centimeters, 10 centimeters and 6 centimeters, because then I can look at what happens when I convert each part separately, okay? Let's start with our 600 centimeters. I'm going to use what I know. So I know that 100 centimeters is 1 meter, and I know that we divided our 100 by 100 to get that 1 meter, okay? So let's think about the 600 meters. I know 100 centimeters is 1 meter, so 600 centimeters has got to be 6 meters. And let's just check it by looking at our division. So we need to do 600 divided by 100, and that would leave us with 6. Okay. Now remember that when we've been looking at going from from centimeters to meters, we have been dividing by 100 each time, haven't we? So that's going to help us out here, because let's look at what 10 centimeters would be in meters. Okay, so I'm going to use my rule. I know that 10 centimeters divided by 100 would be 1/10. Now let's look at what happens there, because we've got to remember our place value columns here, okay? So remember that we would have our 10, and to put our values into a place value column, we'd have a 10, 1/10, and no ones, okay? So 0 to represent the ones column. And then what comes on the other side of my ones column? Well, it's tenths, isn't it? Okay, so I'll put a little t there. So let's look at what happens to the digits when we divide by 100. We need to move them 2 places. So I'll start with my 10 digit. Okay, I'll move it 1 place and then another place. That's where it ends up. I could move my 0 as well, but actually it would go into the hundreds column and I wouldn't need to show that placeholder. But I do need to show that I have got a decimal by putting a placeholder in the units. And what do we end up with? We end up with 1/10, okay? So just remember, you can always make a little sketch of a place value diagram if you need to. So 10 centimeters is 1/10 of a meter, okay? 0.1. Okay, so now let's look at 6 centimeters. So I know that if I'm going from centimeters to meters, I want to divide by 100. So 6 divided by 100, what do you think it's going to be this time? Move it 2 places to the right. Which column will we end up with? Well, we will end up with the hundredths column, because centimeters are 100th of a meter. Okay, there we go. So now I've gone through and we've worked it out separately, haven't we? So let's put them together. So we've got our 616 centimeters, but let's look at how many meters we've got. We've got 6 meters, we've got 0.1 meters, and we've got 0.06 meters. So if I added those together, I'd have 6 meters, 6 in the ones column. I'd have my 1/10, and I've got no ones to add. And then I've got 6/10 and no tenths and no ones to add. So I'd end up with 6.16, or 6 whole meters, and 16 centimeters, okay? 6.16. Now let's look at a fast track for that, because we have got a fast track like yesterday. So to go from our centimeters to our meters, let's divide our centimeters by 100. And we can see there that it ends up with the same amount, doesn't it? So we could do that in the future. So Renaud's height was 616 centimeters, which is the same as 6.16 meters. Now I could write that in another way. Okay, this will come up a bit later. I could separate that out, because I've got 6 whole meters there, and then I've got 16.16, and that would actually be 16 centimeters, okay? Because it's 16 hundredths, and 100 centimeters would be the next meter. Okay, so now we can think about a rule, guys. So to convert centimeters to meters, as we've been doing, what would I need to do? Would I need to multiply the centimeters by 100 or divide the centimeters by 100? Remember, we're going from centimeters, which are bigger numbers, to meters. which are our smaller numbers, but they're the same value, aren't they? Pause the video and have a think. Okay, now read it with me. To convert centimetres to metres, divide the centimetres by 100. Okay, let's look at the next one. So this is Theory's height, and his is 5.80 metres. So now we're going to look at converting another way. So what should we convert this one to? It's already in metres, so there's no point converting it to metres. Let's convert it to centimetres. So what is 5.80 metres as centimetres? Again, you might want to pause the video and see if you can do this one. Okay, so I've split my 5.80 metres into 5 metres and 0.8 metres, okay, 0.8 of a metre. Now let's use what we know to work out what it would be as centimetres. So I'm going to go the other way now. I know that 1 metre is 100 centimetres. Now let's think about what's happened there to our numbers. Have we divided this time? We have multiplied. If I do 1 and I times it by 100, it leaves me with 100. So I know that 1 metre is 100 centimetres. So what would 5 metres be? It would be 5 lots of 100, which would be 500 metres. 5 times 100 is 500. Now let's look at what 0.8 of a metre would be, 0.8. So I know that 0.1 metres would be 10 centimetres. Now, do you agree with me there? Have a think about the rules so far. Hopefully you do agree with me, because we can see that if we had 0.1 and we times it by 100, it would get us to 10. Okay, if we move that digit 1 place and then 2 places, we would end up in the tens column. So I know that 0.1 metre is 10 centimetres. What will 0.8 metres be? It has to be 80 centimetres. And let's check, 0.8 times 100 is 80. Okay, so let's add them together and just make sure we're really happy with this. So let's see how many, I've just noticed a mistake there. Let's see how many centimetres we've got in total. So 5 metres was 500 centimetres and 0.8 metres was 80 centimetres. So we should have 580 centimetres, okay? And let's just double check, could we have done that quicker? So if we took our 5.80 and we times it by 100 from the beginning, it would have gotten us to 580, wouldn't it? So Theory's height was 5.80 metres, which is the same as 580 centimetres. Remember, we've got that 80 again, haven't we there? 80 hundredths. Remember that 100 hundredths makes a whole, and 100 centimetres makes 1 metre. So we could write this, we could actually break it up now, couldn't we? We could write it as 5 metres, and we could write it as 80 centimetres, okay? So let's think about the rule to convert metres to centimetres now. Remember to think, okay, we're going from metres, which are our smaller numbers, to our centimetres, which we've got more of because they're smaller. So what are we going to do? Multiply the metres by 100 or divide? Pause the video and have a think. Okay, now read it with me. To convert metres to centimetres, multiply the metres by 100. Super. So now you've got some guided practice to do. So pause the video now and have a look at the different questions. Okay, so we've got some more pole vault records here completed by a man named Sergei Bubka, and got the different years that he broke those records or made those records and his different measurements here. And the first question said, write each height in meters and centimeters. Okay, so you've got to think about what you know. Okay, remember that there are 100 centimeters in every meter. So hopefully you realized that we could split 614 into 600, which would be 6 meters, 600 centimeters, and then we'd have 14 centimeters left over. With this one, we could split our number into 600 centimeters and 9. So we'd have 600 centimeters, which is 6 meters, and then 9 centimeters left over. And for this one was a bit of a trick. We know that 100 centimeters is 1 meter, so 600 centimeters is 6 meters, and there are no other centimeters. They're all adding up to those 6 meters, aren't they? Now it says to convert each centimeter height into meters. So we're after our decimal here, if there is a decimal. So let's go through these ones now. Okay, 614 centimeters is 6.14 meters, because 614 divided by 100 is 6.14. So we're converting from centimeters to meters, we need to divide by 100. Let's look at the one below. So 609 centimeters is 6.09 meters, because 609 divided by 100 is 6.09. Now let's look at the last one. 600 centimeters is 6 meters, because 600 divided by 100 is 6. Hopefully you have the same reasons as me, something very similar. Now you've got to fill in the missing boxes, so just a bit of extra practice with timesing and dividing by 100. So 0.8 times by 100 is 80. Let's do the one below. Something times by 100 would make 50. So this is a bit of an inverse problem in disguise. So if I did 50 and I divided it by 100, it should be 0.5. And if I check it, yeah, 0.5. If I move that 2 places, I'll end up with 50. Okay, 18 divided by 100 should be 0.18, so 18 hundredths. Now let's look at this one. Something divided by 100 is 0.02. So I have to start with something bigger, don't I? So this is a multiplication in disguise. So if I did 0.02 times by 100, it would leave me with 2. And I can check it. 2, move 2 places to the right would leave me in the hundredths column. So I know this is right. Okay, next one. Would these calculations help us convert centimeters to meters or meters to centimeters? Let's have a think about this. Okay, so just like before, if I grab this, it might help us. If we're going from a smaller number and we're ending up with a larger product, let's think about what that means, okay? We would end up going from our smaller meters to our larger number of centimeters for each meter. So these calculations would help us convert our meters to centimeters, okay? But now let's look at this one. Okay, what do you notice here? We're starting with the larger number here, even though they're still quite small numbers. We're ending up with even smaller parts, aren't we? And so here, I'll maybe change the color. When we're dividing by 100, this would help us convert our centimeters into meters. Yeah, yeah, our centimeters into meters. Just had to check it because we're going from our larger numbers, even though they're not that large, we're ending up with our smaller fractions, okay, our smaller decimals. Okay, now you've got some independent practice to complete, so work through all of those questions really carefully, read those questions, and then there's a table to fill in. And one of your extra tasks today is to perhaps go around your house or look out of your window maybe, or when you're on your walk, maybe you could estimate the heights of some of the objects in your neighborhood or your house, a bit like Ruby did here, because estimating heights in meters and centimeters and maybe even millimeters is a really good skill. There's a deeper thinking challenge. It's quite a meaty one today, so there's just one and then the answers are at the end. So please send your work into Year 5 and good luck everyone. I hope you enjoy. Okay, see you tomorrow. Bye.